Hey, it's me, Steve, and welcome to episode 2 of the Freda Chronicles. I'm just putting this in here, because I received something via email yesterday, but I wanted to make sure I had it all. I got the last set today. But before I show you that, so I'll say, there's a Catenatron right there. I don't know if you see there's a Bela right here. She's cleaning herself. I think you just saw Blackie walk by. But what came via email were the core logs that I requested from Michigan DEQ. Now, there's a reason why I requested core logs. I requested many. They're grouped here, but there's 4 sets. All right, and I did this because I have a wish list, if you will, of cores I actually want to look at, in order to redefine the Freda. Well, if I have the logs in hand, what's the point of looking at the cores? Well, because logs, although detailed, can leave out specific things that I am looking for. Like, this is the St. Amour core. I actually looked at this when I did the Jacobsville. But there's Freda in there as well. And what the core logs do is they'll tell you where they think the lithologic divisions are. And this has all been released to the public. You know, it says confidential. It's not. You see these descriptions here? These are not adequate descriptions. All right. It goes on for several pages like that. And this core, I love this core. This core is almost 7,000 feet deep. All right, I believe that's what it is. Let me double check. Yes, it terminates at 7,238 feet below ground surface, but the actual core doesn't start until 160 feet, which is beneath the glacial drift. And this core is awesome. If you see my Jacobsville paper, you'll see I have some photos in there. The core, typically you don't get cores like this. When I say core, I mean somebody drilled down with a barrel down 7,000 feet to get rock core. It starts out as a 3-inch core, which is really unusual in and of itself. Most rock cores are not that, don't have that kind of diameter. They're usually 2-inch, or in a lot of cases they'll be 1-inch in diameter. All right, but the St. Amour is 3 inches down to, I forget where, but it only narrows down from there until 2 inches. So it's one of the best cores in the world, and it is complete. I think there's maybe a total of 30 feet out of that nearly 7,000 that was unrecoverable, and some people have taken little samples, but they're like sections like that out of it, and you got to put a placer in there saying, you know, missing depth and everything. But sometimes geologists will come along, like these are all from the White Pine Basin. There's a total of 9 here. And they will give better descriptions than drillers will, but still, that may not be good enough. The thing I like about this one, though, is this set if somebody bothered to make cross sections. I'm still trying to figure out exactly where this cross section falls. But those descriptions are better, but there still might be stuff missing. Like, in most of these, they don't mention if the sandstones are arcosic. They'll just say things like siltstones, fine grain sandstone, medium grain, coarse grain. But what is meant by that? Now, a geologist would use the Wentworth scale, describing something like this. The Wentworth scale is a scale of how we divide sands into very fine, medium, coarse, very coarse granulars. And we do the same thing with the silt part of it, and then we do something similar with pebbles and boulders to it, and they're fixed logical intervals. However, if an engineer did this, they may be going off what's called USCS, and those divisions are arbitrary. So they're based off industry standards. So what I think might be a fine to medium sandstone, they might just have as fine. All right. So that's another reason. That's a reason why I need to actually physically look at it. And a lot of times they will put things in here like hematite staining, calcareous cement, stuff like that. But a lot of times they don't. And a lot of times what's missing off here is most of these cores are near flat, like the bedding. You know, bedding is initially laid down flat, but most of these will be slightly tilted. Some are really tilted, like the Say No More. As you go deeper down, I believe the dip becomes almost 20 degrees. You don't know what orientation, which way that dip is pointing from the core, but you can get a general feel of the structure of the surrounding area when you actually physically look at the core. Well, if I need to physically look at these cores, why did I even bother with this? Because I can use these as a guide to narrow down what I need. And I originally had 24 cores, I think, I wanted to look at. 2 don't have logs of those 24 and are not up in the UP in Marquette. They're at Western Michigan, and I ain't going there to look at them. And I think I narrowed it down to about 7. So that's a big help. These really helped me narrow that list down. But I think that's all I wanted to talk about for right now. And I'll keep making these videos as I go through the process of redefining the Freda. And I hope you enjoy them.